Hi, I'm Travis, an application engineer at Maxim Integrated. In this video, I'll show you how to spatially index sensors on a one-wire network. I'll show you a simple circuit that does this, and then demonstrate it with our one-wire thermal camera demo. One of the advantages of the one-wire protocol is that it can operate up to several hundred meters in length, whereas I2C is limited to about a meter. Another advantage is that each device has a unique ROM ID, allowing for multiple of the same device type on a single network. However, in one of these multi-device networks, there's no way to tell where each device is physically located. For example, let's say I want to measure temperature at multiple points around the perimeter of a room. A simple solution would be to connect one-wire temperature sensors like the DS18B20 to a single one-wire bus that runs around the room. After setting up the sensors, I would need to manually index the sensors, matching each ROM ID with a location in the room. That might be okay for a single room, but setting up multiple rooms would quickly become tiresome and time-consuming. With a few more components, we can easily automate this indexing process and add flexibility to our one-wire network.
But wait, what about the DS18B20? Isn't that a one-wire temp sensor with built-in sequence detect?
Well, yeah, that's a good point. The DS18B20 does have this function built in, but other one-wire devices don't. So I'm just using the DS18B20 as an example. Stop ruining my video. So anyways, here's how we can implement an indexing circuit for any other one-wire device. At each sensor, we'll first add a DS2413, which has two one-wire programmable I/O ports. These ports will control a pair of single-pole double-throw analog switches, such as the MAXREFDES131. These switches will serve to connect or disconnect the temperature sensors and the downstream one-wire network. When we power on the system, the DS2413 ports are high by default, which sets the switches to their normally open positions, thereby connecting the local one-wire sensor and disconnecting the downstream one-wire network. Performing a one-wire search command will identify the DS2413 and the DS18B20 as the first ones in the network. Next, we can switch out the local sensor and connect the downstream network to identify the next 2413 and DS18B20, and repeat this process until all the sensors are identified. After you have all the sensors indexed, you can connect or disconnect whichever sensors you want, giving you flexible control over the entire one-wire network. To demonstrate how this works, I will use our MAXREFDES131 GridEYE sensor demo, which uses this indexing scheme with an 8x8 pixel thermal camera sensor. To run this demo, I'll use a laptop with a Demo GUI, a MAX32600 mbed board loaded with the demo firmware, a MAXREFDES132 one-wire shield, and two MAXREFDES131s connected with RJ11 cables in series. In the Demo GUI, I can click Enumerate Sensors, which repeatedly performs a one-wire search algorithm and then connects the downstream sensors until all the sensors are identified. I can then select which sensor, so I'll say Sensor 1, and click Receive Data. The green LED indicates that the sensor is on, and the blue LED flashing indicates that one-wire activity is happening at that sensor. So you can see my hand waving in front of this sensor, and that's a live stream of data. And now if I want to connect the second sensor, I can switch that over, click Receive Data, and now you can see I have a live stream from the second sensor over here. And that's it. Now that you know how to add spatial indexing, you can design flexible and easy to configure one-wire sensor networks. That's it for this video. See you next time.